Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a numerical on equal area criteria with sudden increase in mechanical input. So let us consider the numerical here. A synchronous machine is connected to infinite bus through a tie line. Now here I will draw, this is your synchronous machine which is connected to the infinite bus. The internal voltage of the machine is 1.2 per unit, that is we have given E equal to 1.2 per unit. Infinite bus voltage V equal to 1 at an angle 0, or you can say it is 1 per unit, and the transfer reactance of the line I can say X, which is nothing but 1 per unit. Now what we have given, PM0, that is initial mechanical input, and electrical power PE, it will be equal to what? It will be equal to 0.8 per unit. Determine the stability using equal area criteria when, now there are two cases. Case 1 is when we have a sudden change in the mechanical input or sudden increase in the mechanical input is 1 per unit. So let me solve first for this 1 per unit, then we will go for a next point. Now this is what is the problem of sudden increase in mechanical input. So I will draw a curve here. This is your load angle delta. This will be your PE. So this is your P delta curve. Initially this will be your PM0 and this will be your PM1. Now you know how to draw this curve. So I will first draw this curve. I will complete this and then we will discuss about the things how to solve this. If you see, this is your delta 0, this is your delta 1, this will be your delta max. This is pi, this will be 0. Now this shaded region, it indicates what? It indicates area A1, and this shaded region, it indicates area A2. Now I will give the names here. Let's say this is point number A, this is point number B, and this will be point number C. So let me solve now. Now I will write it here at point A. What is observed at point A? What you have observed here? This PM0 line, it will intersect to the curve PE. Now you know that what is PE? PE equal to, it is P max into sine delta, or you can write P max as what? EV upon X into sine delta. And we have given this PM0 equal to PE, which is equal to 0.8. It is given in the numerator, numerical. So it is 0.8. Now what is the value of E? E is 1.2, V is 1, X is 1 into sine delta. To be precise, I can write it here as a sine delta 0 because here it is sine delta 0. So from this, can I write an equation for delta 0? Yes, it will be equal to what? It will be equal to sine inverse of 0.8 divided by 1.2. So what is the answer of delta 0? If you find it out, you will get answer as 0.7297 radian. So this is the answer of delta 0 where at point A. This is the point A. Now what I will do, I will write it for at point B. What is the equation? Now what you observe at point B, this PM1 and this PE will intersect with each other. So I will write it here, PM1 equal to PE equal to, it will be what? P max into sine delta. Here I will write as delta 1 because to this corresponding delta value is nothing but delta 1, which is equal to E into V upon X into sine delta 1. So let me substitute the values. Now what is increase in the mechanical input? It is 1 per unit. So this is 1 will be equal to P max. Now here E is nothing but 1.2, V is 1, X is 1 into sine delta 1. So from this I can write a value for delta 1 as sine inverse of 1.0 divided by 1.2. So if you solve this, you will get answer for delta 1. Answer for delta 1 will be 0.98511. Please remember, while solving a numerical of equal area criteria, you have to keep your calculator in a radian mode. Now, next is nothing but calculation of delta max. Now, already in the derivation we have studied how to find it out delta max. How to find it out? We have to subtract this portion. This portion means which portion we are going to subtract? This is nothing but your delta max. This will be your delta 1. So how you can write the answer? Delta max will be equal to pi minus delta 1, which will be equal to pi minus 0.98511. So if you calculate, you will get answer as 2.15648 radian. 2.15648 radian. Now from the diagram, can we write equations for area A1 and A2? Yes. What is the equation of area A1? Integration delta 0 to delta 1, upper limit minus lower limit. So what is your upper limit? Here if you see, upper limit is the PM1. So it looks like this. It looks like this. This is your PM1, and lower limit is nothing but what? It is your PE. So how I can write here? It will be PM1 minus PE d delta. So if I substitute here delta 0 to delta 1, PM1 as it is, PE will be equal to what? It is P max into sine delta d delta. So I will now solve this equation. PM1 into bracket, upper limit is delta 1 minus lower limit delta 0 minus P max. Now what is integration of sine? It is minus cos. So it will be what? Minus cos delta 1 plus cos delta 0. This is your equation number, you can say A1. This is equation A1. So now what we will do, we will have all the values. PM1 is 1.0, delta 1 is 0.98511, delta 0 already we have determined, it comes out to be 0.7297 radian. Then Pmax is EV upon X, which is equal to 1.2 into 1 upon 1, means 1.2 only. Then you can substitute delta 1 and delta 2. So after substituting all the values, you will get the answer for A1, and it comes out to be 0.0243. It comes out to be what? 0.0243. Similarly, we can write an equation for area A2. So how I can write? Area A2 will be equal to integration delta 1 to delta max. Now please see it carefully, the diagram. This is now upper limit. Now so diagram looks like this. It will be like this. Okay. So this is your upper limit is PE, lower limit is what? PM1. So therefore, how you can write a formula? It will be PE minus PM1 into d delta, which is equal to what? Delta 1 to delta max. PE means it is P max sine delta minus PM1 into d delta. So if I substitute all the limits, then what I will get? P max will be as it is into bracket. Now integration of sine is minus cos, so upper limit will be what? Minus cos delta max, minus minus becomes plus cos delta 1 minus PM1 into bracket, upper limit is delta max minus lower limit will be delta 1. So again, you know all the values, you know P max, already we have determined the value of delta max and delta 1. So please substitute this and just calculate the answer for A2. It comes out to be 0.1553. Now as far as equal area criteria is concerned, we know that when the system will be stable, if area A2 is greater than or equal to A1, then only your system will be stable. So what you observe here? What is the answer for area A2? 0.1553. What is the answer for area A1? 0.0243. So as area A2 is greater than area A1, system will be stable. So therefore I can write when mechanical input is suddenly increased to 1 per unit from 0.8, what it is observed, system will be stable. So this is the first part that we did here. This was the first part here. What happens to the stability when we have a sudden increase in mechanical input is 1 per unit. Now we have a second case is 1.1 per unit. Now we will solve it in the same way. I'm not going to solve it again, because we have to, what we have to do here, we have to just replace the value of PM1 as 1.1 per unit in all above steps, and you just have to find it out. So you can start from this only. You know this is 0.8 equal to 1.2 into 1 upon 1. There will not be any change in the value of delta 0. Delta 0 will be 0.7297 as it is. Then if you want to find it out delta 1, now here initially in first case PM1 was 1.1. Now here we have to take this as a PM1 was 1 initially. Here we have to take now PM1 as 1.1. So 1.1 equal to 1.2 into 1 upon 1 sin delta 1. So from that you can find it out delta 1. Once you find it out delta 1, then you can find it out value of delta max. Similarly, write down equations of A1, A2, substitute all the values. So I will write directly answers here. Delta 0 will be as it is, which is not going to change. So 0.7297 radian, it is as it is. Now delta 1, we can find it out the same step which was used in the previous one. It is 1.1597 radian. Delta 1 comes out to be this. Then we can find it out delta max will be equal to pi minus delta 1. So it comes out to be 1.9819. Then write down the equations for area A1 and A2. So if we write equation for area A1, if we substitute all the values that we have, we will get answer for area A1 as 0.0581. Similarly, if we write equation for deaccelerating area A2, if we substitute all the values, then we will get answer for area A2 is 0.0547. Now what is observed here? It is observed that as A1 is greater than A2, as far as equal area criteria is concerned, the system will be unstable. So how I can write the last sentence? When PM1, that is sudden increase in mechanical input, is 1.1 per unit from 0.8 per unit, then here I can write it as system will be unstable. So this is what is the numerical here we have solved for sudden increase in the mechanical input. If you have any doubt, please feel free to ask. Thank you for watching this video.